Well, I have my Chapter 7 test coming up on Friday, so I figured we could just go over a few things throughout the chapter.
Okay.
I'm feeling pretty comfortable with the majority of it. It's just a few things I kind of want to, I'm doing this correctly, right? Sort of thing, so yeah.
Okay, let's see. I've got my algebra book in my office tonight. Uh,
All right.
you have exercises at the end of the book?
Uh-huh. She wanted us to do the Chapter 7 test on page 459, numbers 1 through 29.
Okay, I've got those problems. First one is cube root of negative 1,000.
Yep.
Okay. So what is the cube root of negative 1,000?
I got it to be negative 10.
Uh-huh. Because negative 10 times negative 10 times negative 10 is negative 1,000.
Yep.
Okay. 4 to the 5 halves power. When you have a fractional exponent like this, you're taking the denominator as the root and the numerator as the exponent. So this is, I could write this the same as the square root of 4 to the 5th power. But
Yep.
that's hard to do because 4 to the 5th power is a big number. So you're always better off taking the denominator first, and you will end up with much smaller numbers. In other words, if I take the square root of 4 first, that's 2, and now I know that 2 to the 5th power is 32.
Right.
I didn't have to
Okay.
deal with as big a number.
Yeah. All right.
Okay. Now, do you want to just go through each one of these one by one, or do you want, are you good with some of these and you don't need to do them?
I've already done quite a few of these. There was just a few that I was having a bit of trouble with that I was hoping to go over you just to get out of the way.
Which ones? Why don't we start with those?
Number 6 was the first one.
Okay. So 2 to the 1/3 times 5 to the 1/2. Notice the problem with just that expression. I've got different bases and different exponents. So generally I can't do much with that. But now they're taking the whole thing to the 4th power. And now I can apply the rules of exponents. So what does that equal to?
So then that would be 2 to the 4/12.
4/3. So all you do
Oh,
is multiply the 4 times the 1/3.
oh, okay. And then 5 to the 4/2, then, so 5 squared.
Right. Now I can't do much with that. Let's see, 2 to the 4th is 16, and 16 is not a perfect cube number. So the only way you're going to get an answer from that is from your calculator. Do you know how to do that on the calculator?
Yep.
Okay, cool. You could do it a couple of ways. You could do it 2 raised to the 1.33, which isn't quite exact, but you could also do it 2 raised to the parentheses 4/3. Make sure you put that exponent in parentheses when it's fractional like this.
Okay. So then I got 2.519, basically.
Okay, but then you got to multiply it by 5 squared, which is 25.
All right, so that got me 62.996.
Okay. Did they give you how you're supposed to round those off? Or did they even want you to turn it into a decimal?
I don't know if they even wanted us to turn it into a decimal.
Yeah, well, I noticed the directions on 1 through 5 were do it without a calculator. 6 through 10, assume all variables are positive. Simplify the expression. I'm not convinced they want you to turn that into a decimal.
Okay.
Whenever you turn something into a decimal, you make it less accurate. In other
Yeah.
words, if I'm talking about the square root of 2 and somebody says, what's the most accurate expression? Well, it's not the decimal. That goes on and on forever. It's this right here. That's how I'm given my answer because that is 100% accurate.
Okay.
So for this problem that we just did, it didn't give any instructions about rounding off the decimal, so I'd be reluctant to turn it into a decimal. I would give the answer like this: 25 times 2 to the 4/3.
Okay.
And you could do that in a number of ways. You could do 25 times the cube root of 2 to the 4th. Could write it like that also. Or I could do 25 times the cube root of 16, which is 2 to the 4th. So this, I can guarantee you, would not lose you any points. Depending on your teacher, I don't know how far she wants you to simplify it. This is simplified, but even that can be simplified a little bit. Let's talk about that. Cube root of 16. Well, 16 can be written as 8 times 2, and the cube root of 8 is a whole number, so this becomes 2 cube root of 2. That's what 16 is. So I can actually multiply that, and then I got 2 times 25, so that actually becomes 50 cube root of 2, and that's simplified.
Okay.
That's going to be the answer they want, this right here.
All right.
Okay?
Okay.
Number 7.
Number 7 I got pretty well. The next one that I had the most trouble with, I'd say, was probably number 9.
Okay. All of these exponential problems, in other words, whenever you have multiplication taking place or division, then I can multiply that. This is the same thing as 81x squared to the 3/4 divided by y to the 3/4. It's an important consideration to realize you can always do that.
Okay.
Now let's take the top. What's 81 to the 3/4 power? What's the 4th root of 81? Remember, you're always going to have small whole numbers for these kind of problems. Hold it.
Is that going to be
What's
3?
a small whole number that represents the 4th root of 81?
Is that number 3?
Uh-huh. And then I would have 3 cubed. So that turns into 27. That's what 81 to the 3/4 power is. And then multiplying these two exponents gives me x to the 6/4, which is the same as x to the 3/2, which is the same as x times x to the 1/2, or square root of x. So I can write the top like that. Bottom I can't do much with. Pretty much I'm stuck with that. And I could write the top in a different way. I could write it as 27 times x to the 3/2 divided by y to the 3/4. So I could write it like that. I don't see what else I can do though. A lot of these you could get by with a number of answers that are the same but look different. In other words, that's the same as this. Looks a little different, but I'm not quite sure how far down they want you to simplify. My guess the top maybe would be the the preferred answer. Because you can simplify x to the 3/2. You can pull a full x out of that.
Yeah. All right.
But number 10, you know how to do 10?
Yeah, number 10, what I did for that one was just, or since they're both just the square root, I just added them together. And then you can't square, or 218 doesn't have an even
Yeah, you
small.
can't really add these two together as long as they're different. And this is the square root of 18, this is the square root of 200. So in the simplification process, this turns into 9 times 2, which turns into 3 root 2. And this turns into 100 times 2, which turns into 10 root 2. Now I got root 2. Those are apples and apples. I can add those. If I have 3 apples and 10 apples, I got 13 apples. So I end up with 13 root 2. So the secret to these problems is always to see if you can simplify it and what you're left with is the same number in the radical. And they almost always are, otherwise they wouldn't give you the problem. In other words, if this was the square root of 300, wouldn't work. I'm going to have 10 root 3, and I cannot add a root 3 to a root 2.
Okay.
Okay?
Yeah, I understand how that happened then.
Okay.
So, okay.
What next?
The next one was, so with 11 through 16, I understand how to perform the indicated operation, like the f plus g or the f times g of x and stuff like that, but, how do you state the domain of those? So can we just go over that with one of them?
Yeah. Let's do 13. The domain on the first couple are going to be relatively easy because it's going to be all real number. And no, it won't be. It'll be all even numbers. In other words, when you add the two functions together, 11, you get 4x minus 8, right?
Right.
That's all real numbers for the domain. When you subtract them on 12, you get minus 3x to the 1/4. You see how I get that?
Yeah, I do.
Well, x to the 1/4 is the 4th root. That's an even root. So I can only take even roots of numbers that are greater than or equal to 0. So the domain on 12 is x greater than or equal to 0.
Okay.
Now when you get to 13, the rules change a little bit. Let's go over 13.
All right.
F of x is 5x plus 7, and g of x is x minus 9. So they want f dot g means f of g of x. Okay, that's what it means. It means this. In other words, I can write that in a couple of ways. To me, this is the best way to write it. Because now I can say, well, what I'm really doing is f of g of x is x minus 9. So I'm going to take f of x minus 9. How do I take f of x minus 9 if f of x is 5x plus 7?
So that would be 5 parenthesis x minus 9 parenthesis plus 7.
Yeah. And we can see that that doesn't have any domain restrictions on it either.
Okay.
However, some of these are really interesting because your final f of g may not look like it has domain restrictions, but it does. I'm looking for one that might be like that. Let's look at 14. 14. F of x equals x to the 1/5, negative 1/5. So I'm going to write that like this. See that that's the proper way to handle negative exponents?
Yep, you take the reciprocal.
Okay. And this is x to the 3/5. As all they're doing is dividing this. Let me think for a moment here. They're dividing f by g. It's going to give you the same domain restrictions, I think. No, it isn't. Yeah, this is a good problem here. Because f of x, I'm going to take it back to the negative 1/5. Actually, it ends up being easier if I do this. What's that equal to?
That's x, or 1 over x to the 4/5.
Subtract exponents. In other words, I'm doing division, same base, so there's my top exponent. I'm subtracting that exponent. You were right. That's negative 4/5, which is 1 over x to the 4/5. The domain, I'm trying to find a problem where the domain of the final answer is not the domain. In other words, here's the rules. First of all, the domain of this, the final answer, is what? Everything except what?
Everything except 1 or 0.
0. The first rule of math is you cannot divide by 0. So I can do everything else. In other words, because it's an odd root, x can be negative or x can be positive. The only thing I can't have is a 0 for x, because then I'm dividing by 0. So this is all reals except x cannot be 0. Okay? Well, if I go up and look at f of x and g of x has no domain restrictions at all. That's all reals.
Right.
F of x has that same domain restriction that x cannot be 0. What you're going to run into, and I had a student that had one of these just the other day, was, it was the x minus 8 one. Except it was a composite function with that x minus 8. Anyway, we ended up with a function that looked kind of like this. Well, that has a domain of all reals except x cannot be equal to 8, right?
Right.
But one of the original functions was 1 over x, which meant that the original function's domain restriction included x cannot be equal to 0. And so that was the answer. In other words, just because an apparent domain restriction looks like it disappears, it doesn't. You always have to use the most restrictive domain of your f function or your g function or the f of g function.
Okay. So it would be both, so it would be 1 over x minus 8, but x cannot equal 0 or 8?
Correct. Exactly. And, gosh, I don't have the problem in front of me. Let's do 16. Maybe it'll do it. Maybe even 15 does it. Let me think for a second. No, there's not going to be any domain restrictions there. Yeah, I don't think 16 will have any either, but let's look at 16.
Okay.
So this one wants g of f of x with f of x being x squared plus 3x and g of x being 2x plus 1. So what's the first thing I should write?
So the first thing that you would write would be 2 parentheses x squared plus 3x parentheses plus 1.
Yeah, that's kind of shortcutting a step out, which I don't have any problem with. If you seem to know what you're doing here. When I'm teaching this, I always am going to do this. Whoops. Put the wrong function in there, not that. I'm always going to put this step in here. In other words, I want to figure out what that is. Well, I go to my g function, and wherever I find x, I substitute what's in the parentheses. So g of this is going to be 2 times, is this what you said?
Yep.
Okay. And then simplify it. And you end up with 2x squared plus 6x plus 1. No domain restrictions at all there, none there, none there. In other words, you do have to check all three functions, the individuals and the composite, for domain restrictions.
Okay.
Were you supposed to do just 1 through 16?
1 through 29.
Okay. Let's look at some inverse functions. Are you good with inverse functions?
Yeah, I'm pretty good with inverse functions.
Switch the variables and then solve for y.
Right.
That's all you need to know, really.
Yep.
In other words, turn your f of x into y, and then switch the variables and solve for y.
Yep.
Okay, 21. What's the domain and range?
So, the domain for 21 would be sorry, 6 to infinity.
Okay.
And the range.
The way you want to figure these domains out is no matter how complicated the expression under the radical sign, just go over here and make that expression greater than or equal to 0 and then solve it. In other words, I could make this super complicated. I could put x minus 6 over x squared plus 2, would not matter. Start there. That tells you what your domain's going to be. Let's see.
All right.
So the domain is x has to be greater than or equal to 6. What's the range?
The range, since it doesn't have a plus or minus outside of the radical, it would just be 0 to infinity, right?
Correct. Positive numbers only, or 0. And in terms of graphing it, if I start with the parent function, that's the square root of x. How is this transformed from the parent function?
It's shifted to the right 6 units.
Correct. So this function would look like that.
Yeah, okay.
Positive number shifts to the left, negative number shifts to the right.
Yeah. Okay.
What's the domain on 22?
The domain on 22 is just all real numbers.
What's the range?
All real numbers as well.
Correct.
Awesome.
And let me see if I can find another interesting one. What's the domain on 24?
The domain on 24?
Mm-hmm.
Would that be 0 to infinity?
Correct. What's the range?
4 to infinity.
Good. Because x to the 1/2 is always positive, And so you kind of want to see no, not 4 to infinity.
Not?
I made a mistake there. I was looking at it a little bit wrong. What's the range on that?
The range?
We know the domain on just that part that I've circled is 0 to infinity.
Is it 0, or would the range be then 4 to negative infinity?
It would be 0 or negative infinity to 0. There's no way to make what I have circled positive. For it to be positive, this would have to be positive. And this can't be positive, x to the 1/2. That's always negative. Excuse me. In order to make what I have circled positive, I would have to be able to make x to the 1/2 negative, and I can't do it. So
Okay.
the range on this part is negative infinity to 0, which means the range on the entire part is negative infinity to 4.
All right.
In other words, certainly if x is infinity, square root of it's infinity times minus 2 is minus infinity. Add 4, still minus infinity. But if this whole part that I have circled were to go to 0, then I could get the value up to 4. But I'm never getting it above 4.
Okay.
So I can be anywhere from negative infinity to 4. All right. You good to go, or do you have any that you would like to ask about before I let you go?
I think that I'm pretty good with that. I understand the rest of them, especially with like the extraneous solutions. I'm pretty good with those. So, yeah, I think I'm good. Thank you so much.
Yeah, extraneous solutions, incidentally, generally come about when you see radical signs, absolute value signs, or log signs, log functions. If
Okay.
just a straight polynomial, you almost never have an extraneous solution. But when you see a lot of radical signs, make sure you always check both solutions. A lot of times one of them is extraneous.
Okay.
Okay? All right, Morgan. You have a good week. I'll talk to you next time.
All right. Thanks. You too.